I got a Westinghouse LCD TV here that a friend of mine found in the trash, and let's see if it still works. Okay, got a red power outlet here. Okay, so the red light went to green, but nothing's happening. I don't hear anything, I don't see anything. So the control voltage is getting to the power, and but it's just not powering up the inverters or the sound. Okay, so I want to open up this TV. There's 3 screws on the perimeter on this side, 2 here, 3 more on this side. There's 4 holding the base on, 2 on each side of the base, and then there's 3 screws right there, 2 up here, and then 2 right there, and I'll take those out and hopefully I can get the back off. Alright, well, this TV has been infected with bad capacitors. I got 2 bulging capacitors right here on the power supply, and then on the inverter for the backlight we got 1 right there bulging. That really sucks, but those are the only ones that I see bulging, but it's hard to tell if any of the others are actually bad also, but just not showing symptoms. Okay, so for this board here, you got 4 screws, 1, 2, 3, 4, and then this plug, there's a squeeze lock, so squeeze it, unplug it, and then you got these 2 plugs down here. You just pull and wiggle and they come out. Pull and wiggle. There we go. To get this plug out, I got a screwdriver down in there. It's a little tough to just pull on the wires. For these, they got some glue on them. Just break that loose. Alright, so they got some glue on them, so they might give you some resistance. Push on the tab and pull them out. If they are giving you some resistance, push on the tab, make sure it's unlocked, and then use a screwdriver to kind of break it loose. There you go. This one's glued on pretty good. So just get a screwdriver under that tab, kind of pry it. Yep, that got it. There we go. There we go. Alright. Screws. 1, 2, 3, 4, 5. So I'll show you what all I changed here for the capacitors. Changed 4 1000 microfarad 25 volt right there, right there, right there, and right there. Then I changed the 470 microfarad 35 volt right there, and then also on the inverter board right there. And then I changed out these 2 big 680 microfarad 35 volt capacitors. Got it plugged in, and Let's see if it works. Well, green light, that's good. Come on. So after replacing the bad capacitors, it still won't power on. After I unplugged the inverter board here, you could hear sound coming out of the speaker, so it was powering on when this was disconnected. And when I reconnected it, the sound went away. So there's an issue with this board, and I checked this plug. You got your 24 volt line and your ground. So I went ahead and ohmed across the two to see what we have, to see if we have a ground. Sure enough, there's a short from the 24 volt line to ground showing 3.6 ohms. And if you want to use your buzzer instead of looking at the ohms, and you got a short, yay. So I need to trace where all the 24 volt line goes and see what's shorted out. And on the back is where we have our semiconductor components that are most likely to be the ones shorting out. I mean, you could have a chip cap, semiconductor transistor, and also these ceramic caps tend to short out, but it's not that, and I assume it's one of these four devices. So I'll have to start removing components that are attached to the 24 volt line until the short goes away. It's going to be a long process.
Okay, so I narrowed it down to a couple areas. So there's this diode here. It reads 16 ohms pretty much in both directions. And then I also got these transistors that are reading almost dead short, so 3.5 ohms from one leg to another. That one is a dead short, 6 ohms. Alright, so I'm either thinking it's one of these or both of them, and then this diode right here. So I need to start isolating them from the circuit to find out which one it is. So I'm probably going to start with these because I can just clip the legs and then lift up a couple legs to see if the short goes away. So since this one shows the direct short from there to there as a direct short, I'm going to go ahead and clip the lead on this and see if I can get that short to go away. Make sure it's completely isolated, and right there it is. So let's see if the short's gone. And it's gone. But I bet if I put it, now I'm going to put it on the leg of the transistor, see if it's still there. Yep. So it's still shorted on this, but when I do it to the pad, the short's gone, but on the leg, still there. So this one's definitely shorted. Let's see if this one looks any better. That still looks pretty bad. So let's clip that one also. Alright. Let's measure this one. Now I'm going to the pad. Alright, no more short. Now I'm going to the transistor leg. Come on. And the short's still there. So let's check out this diode. Let's see if the diode's still showing bad. Nope, looks good in both directions. So these two transistors, let's replace those and see if we can get this thing working. QM4003 P-channel MOSFET and its replacement that I used, and the QM4004 N-channel MOSFET and the replacement part that I used. Alright, I got my new N-channel and P-channel MOSFET, 40 volt MOSFET actually, installed, and let's go ahead and put it back in the TV and see if it works. The way I removed it was I clipped the leads, and then I just put the soldering iron on the heatsink, and then I was able to lift it off, and then I took the pieces of leads off the pads and cleaned them up with some solder wick, and then also cleaned up the heatsink side, and then put the new ones on. So let's go ahead and try it. That's the moment of truth. Let's plug it in and see what happens. It's plugged in. We got a red light up here. It's a menu. Oh, power button's on the bottom. Ooh, look at that. Well, I heard it whistle for a little bit. Alright, so when I power this up, lights up, you get that high-pitched whine, and it shuts down the inverter. The TV's still on. It's kind of quiet, but you can't hear it, but you can, there's static coming from the speakers. Anyhow, so I expected this capacitor was maybe the reason that everything kept screwing up. So I put a couple of high voltage capacitors in parallel with it to help it, and sure enough, see that? We got a backlight. So let's just take a look at it and see. Yep. Looks perfect. Working great. Alright, so just need to replace this capacitor now, which I wish I had ordered, but I'll get one coming, and this TV will be fixed after that last part there. Oh, that was a major pain. Even though this capacitor shows no physical signs of going bad, it actually is bad. It just loses its capacitance over time, and it just wasn't able to keep up with this switching power supply and the demand that it needed with the lower capacitance. Then it went bad, so that's why putting these two capacitors in parallel was able to give it enough capacitance to start working. I'm just glad it's finally working, because this was irritating me big time. But it's fixed. I'll get a new capacitor and I'll show you how it works with that. So this capacitor here is a 82 microfarad, 450 volt. Okay, so I learned a very valuable lesson, and I would like to teach it all to you before you end up doing the same thing that I just did. On the last video, I showed you how it was actually working when I put the other capacitors in parallel with it. Well, right after I stopped recording, I wanted to take the capacitors off, and so I discharged it. And I just did a hard discharge, not thinking it would be a big deal. Just put a screwdriver across it, and there were some sparks. Thought everything was fine. Got the capacitors off and tried it again, and now it doesn't do anything. It does try to power up, but it just shows a blank screen. It doesn't bring up that big W anymore. I even try to put the capacitors back in parallel with it, and it doesn't work even with those. So doing a hard discharge on that main filter cap there destroys it. I don't know what it does. It's not worth spending any more money on this unit. It's just a cheap little LCD TV. But I'm going to have to tell the person that gave it to me to fix how stupid I am and what I did. But I'll show you how to discharge it correctly. You could even just wait a good 10 minutes and then check the voltage across that capacitor and see if it's discharged enough to matter. But if you're impatient like I got, I'll show you how to put a discharge resistor across it to bleed off the voltage gradually instead of very sudden, which must have put a high voltage to something sensitive and caused it to fail. But you did see that it did work. I mean, this was the last thing I had to replace. I'm really irritated that this happened. But you know what you need to do to fix it. And you know that instead of just putting a screwdriver across that capacitor to discharge it before removing it, you need to just put a resistor across it to bleed the voltage off slowly instead of sudden. So let me show you how to do that here. Okay, so I'll show you here how the TV is no longer working. It does light up the backlight, but yeah, there you go. It's ruined. Now I'll show you how to properly discharge that capacitor. Alright, so I'm going to use a 100K resistor. It's brown, black, orange. Okay, so since I'm using a 100K resistor, I'll show you how to calculate how long it should take for it to discharge. So 100,000 ohms. You just take the resistance times the capacitance, but so it'd be 100,000 ohms times then 82 microfarad would be 0.000082. So right there, it's already equaled it up. That would take 8.2 seconds for that capacitor to fully discharge with a 100K resistor across it. So let's go ahead and do that. Alright, now I'm going to show you how to discharge it properly. Typically you would have the capacitor in the circuit, but I took it out for troubleshooting purposes. I got it plugged in. I'm going to go ahead and power it on to put some voltage to it. You'll see the backlight light up there. Yep, there it goes. So we know it's got voltage on it. Shut it off. And then you want to make sure you unplug it. So it's unplugged. And here's my 100 kilo ohm resistor. And you want to grab it with a pair of insulated needle nose pliers. You don't want to be risking electrical shock here. So there you can see I've got needle nose pliers. Then you would just come in here and put it across the two leads of the capacitor, and then you want to hold it there for the 8 seconds it requires to discharge. Alright, should be good.